Dylan Ho is Senior Software Engineer at ShopBack. ShopBack is an e-commerce company. Dylan Ho is a full-stack engineer with impressive job experience. He is also a big-time board games lover. This makes sense given that he worked as a game developer before. He will present to us navigating Rust's memory maze, a newcomer's journey in prototyping. He will present to us navigating Rust's memory maze, a newcomer's journey in prototyping.
In the accounts identity team. That was great. And actually, I met a lot of people who were doing C++. I'll take a small tangent here. Google has a lot of legacy code, and C++ is a famously difficult to manage language because there's just a lot of complexity there and maintaining it and errors. And so actually they're looking for a language that will supersede C++. And so there's like literally a 50-page document about the other languages that they consider and whether they are interoperable. And Rust is actually one of the shortlisted candidates to replace C++ in Google. And actually, I have one more tidbit I'll share at the end of the presentation about that. By the way, Java already decided the superseder, which is Kotlin. So actually, both the legacy languages of Java and C++ are looking for successors. But Java's done, and Kotlin's great, by the way, I love it. And but C++ is still looking for a successor. I'm currently at ShopBack in the backend doing payments. Our language and in the backend language is actually TypeScript Node, which is controversial, a little bit puke-worthy, but because it's almost the exact opposite language as Rust, because it's the Wild Wild West. You let the garbage collector do everything. Memory leaks if you want to, just make them as much as you want. And there's no ownership, there's no memory allocation. But I think what's cool is that I've been to a lot of different companies. I've touched so many different languages, and what's one more? Let's just deal with Rust. I'm very friendly, so come say hi after this. What was I gonna say? I forgot. So let's move on. Cool. So what's the motivation? What's the project? So I'm a huge board gamer, and someone recently bought me Eclipse Second Dawn for the Galaxy, which is a ridiculously large war game. It's like Risk in space. You get spaceships. You upgrade them with bigger hulls, with lasers, with shields, computer targeting systems. And what happened was that I was playing a 1 versus 1 game with my wife, and I lost. And I claim that I'm super unlucky. I should have won. Okay, this is dumb. Like, I'm just really bad at rolling dice. So what I'll do is I'll prove that I'm unlucky and I'm a good player instead. So I'll make a simulation runner. We run 10,000 simulations, and I bet in 85% of them I'm supposed to win. And I think there's a really low chance, 15% chance to lose. Yeah, so that's the plan. All right, so we're just doing Rust. We'll see how it goes. So we'll see by the end of the presentation whether I was right. Cool. So it's important to have product requirements because you don't want to go over scope. You want to know what you want to plan. You want to know what the milestones that you want to get there. So we have to simulate a battle between two armies, attacker and defender. For the start, we'll just use one ship type versus another ship type. In Eclipse, you can have multiple ship types. Run 10,000 simulations, see how many times the attacker is supposed to win. If it's nice to have, we can add multiple ships to it, intelligent damage assignment, graph statistics, a whole shebang. We'll see how far we'll go in about 4 or 5 hours, which I allocated to this project. Cool. The project is done, it works. If you want to go through it, it's the public repo on GitHub. You can go take a look at my Rust code. Make a merge request, make issues, go ahead. Say again?
May I take a snapshot?
Of course. Yeah. Yeah. Cool. It's like 200 lines of Rust. So cool. So let's go through some of the issues that we talked about just now. Just now, Steve talked about strings being in the stack and strings being in the heap. That is correct because of this problem. So first of all, I was typing my constructor and I was building this cruiser object class struct. And here there's this amazing error. Expected string found %str string. What? So then I started Googling and I found out there are 3 strings. Okay, the string, @string, and @str. And so this is all to do with, that is right, there are 3 kinds of strings. And as far as I understand it, some string, if you have a string that is for example, with the double quotation marks, then it is a bounded string with the allocated memory already. So it is a @str. But then what I'm looking for in the constructor doesn't know how long the string is going to be, so it's an unbounded string, it deserves to go in the heap. Okay? So, wow. So I roughly understand why we do it. I just don't understand why we do it in 2023. Okay, because coming from a very Wild West area of JavaScript and Python, this is way too much thinking for me. And eventually, the solution here is actually to cast it to a string and then basically take ownership of this and then pass it to the constructor. One of the first issues I came into. It's a bit annoying. And let's go to some other things. This is about ownership and like borrowing ownership. So I am currently running a simulation where I'm putting a ship versus a ship, and I'm like decrementing values in the number of ships because the ship got destroyed. And then I get this: you cannot borrow a mutable thingy. You cannot take ownership of self. And that's the most ridiculous thing ever. If I don't own myself, then who owns me? Like, ridiculous. So it turns out that you need to specifically make sure that, first of all, you pass by reference, because if you pass by value, then you change it, then you need to replace the original value, it's immutable as well. So what you do is you pass by reference and you make sure that it's mutable. So you get all these very special errors that you don't normally get in a Wild West language like JavaScript or Python. It was a bit annoying. We came over it, we overcame it. And last error, which I actually didn't make a slide for, was that I tried to pass an array into a function parameter, and bam, we get error again, because you do not know how long the function parameter will be, because it's unbounded length. You need to pass a vector or something, so I need to cast the vector and then pass it through. And I had a lot of, to be honest, I had a lot of trouble writing the Rust, all to the more that I finished the MVP, the minimum viable product, and then we didn't get into any of the extra features. So anyways, the answer to the last question is everything's immutable by default. Make sure you cast it as mutable, and then mutate it there from then on. Cool. Let's talk about some pros and cons. So the pros of Rust. I tried a new language. Yay! Add one more to the thing. You can. I've touched Rust. It's cool. I think it's really succinct. It's readable. It is a very beautiful language. I didn't malloc anything. Okay, so you can't force me to learn anything I don't want to learn. Okay. Because all I had to do was look at the error messages were wonderful. They just tell me, oh, please cast this away. This thing's not mutable. Consider adding mutable. And I thought the execution speed of running 10,000 simulations was really fast, finished in under a second, which is great. Some cons, which the exact three things I listed out just now. I don't really understand what borrowing ownership is. I've read the documentation, I've read the understanding, I've read the rationales. I just don't think that. I just don't think that this is something that I want to deal with in 2023. Okay? I still think that string is too many strings. We should have one is the correct number of strings. And then again, arrays and vectors instead.
There are actually 5 more or something like that.
Excellent. Now I'm not surprised one bit. Okay, so after finishing the project, I ran 10,000 battles and I only won 60% of the time. So it means I'm unlucky. But I was also a sore loser. So I was roughly gonna lose to my wife. That was not the only decision went wrong. I couldn't prove that I was just a good player. That's what it is. But that's not about the conclusion. When you're prototyping a thing, maybe some business logic, something simple like this, you want to make a quick thing. JavaScript, Python, these are very fast prototyping iterative languages. You don't need to deal with it. In the 4 hours that I dealt with it, 3 hours was spent reading Stack Overflow about what a string, about borrowing, ownership, mutables, vectors, how do I deal with this, how do I deal with that, like traits and boxes. Especially from someone who doesn't come from memory allocation background, I totally don't really understand the rationale of this. And also, Steve gave me the green light to it's okay to love or hate Rust. In Google, the conclusion actually, unfortunately, is that C++ is not being superseded by Rust. It's being superseded by Carbon, which is just another language that Dylan could be forced to try out as well. Now the reason is this, it's a bit weird of a reason. Kotlin is great for Java because it's completely interoperable. Half your code base can be, half your service can be in Java, half service can be in Kotlin. For Rust, it is not obviously interoperable with C++, but Carbon is made that way. And so for that was one of the reasons. Yes?
But Carbon doesn't really have the tooling involved, even compared to something new like Zip.
Yeah, so Google is always in a funny spot where it's trying to decide but you know how many languages I Google? All of them. Every single one, every language is done. So Zig probably is in there as well. You have to come to a decision about sort of maturity and maturity versus like ease of use. And I think Google sort of has come to the decision that Carbon is mature enough, well-known enough, and interoperable enough that it will be replacing C++. Unfortunately, I don't have enough more context on this. I didn't read the 50-page document, and unfortunately, I also was on the Java Kotlin side of Google. So yes.
Like even then, I went to the GitHub. I'm not sure how to like build the thing and run it.
Carbon.
Yeah, like it's just an internal project.
Yeah. Anyways, lots of Google tools are completely. There's a lot of tooling and compilers and build files that are in Google stuff that is only used by Google from Google within. And it's not. I don't know whether it's. I just don't have the context to answer your question about how do you run Carbon.
Like even comparing to like Rust itself, like Rust took some time for it to like become widely popular and stuff like that. Like it went from an internal project within Mozilla, and like took some time. It's not like immediately like half a year or 1 year, just immediately everyone starts learning Carbon.
Okay.
I think that's also applying for all languages when you really think about it, right? Because if you see like Mojolang, Bun, everything, I think it's just taking time. That's all. Yeah.
I think that the successor for Java has already decided to be Kotlin. I think right now Google is trying to move forward with Carbon. There is still time for change, and I'm nowhere even close to even being anywhere near the decision making for this. So I will say that I was discussing this with friends and talking about where Rust is useful. Take note that so I have the privilege of working in a few startups in Singapore, and a lot of these startups, Carousel, Grab, Shopee, ShopBack, are all rushing for profitability, right? And they're looking for writing a lot of quick business logic quickly. They're hiring a lot of engineers. And did you know that one of the biggest challenges is actually finding engineers that can write the language, maintain the language. And Golang is already hard enough challenge to find anyone who write Go. And like so, whenever you are picking a language, you have to sort of want to make a difficult decision of, will I be able to find engineers to write these languages? And I argue again that it is easier to find TypeScript engineers, Python engineers, to a certain extent Golang engineers. And if you hire an engineer who doesn't know Rust, and you come in and you see these pointers and these references and these things, and you're wondering how long do I need to give them before they're comfortable with Rust? I think if you are doing a quick prototype, if speed of writing new code is important, you might want to stick to a more 2023 language. sorry, pardon my disrespect. But seriously, right now the reason I think this is important is this. Memory is cheap. CPU speed is cheap. Cores and on Amazon SP are cheap. Garbage collection is cheap. So these are things that you have no issue scaling up, scaling horizontally, scaling vertically. You can afford any of these because that's not the bottleneck you're having right now. One bottleneck is speed of execution. However, I think Rust is useful if you are looking for high velocity quantitative trading. You're looking for where speed and logs and memory leaks are very important to you. And more importantly, if you're in a very low level system where, for example, I have a friend who actually created a project where he had an Arduino and he had a camera on it. He was trying to make a self-driving car, but all he knew was Python, and it was terrible because Python cannot schedule on the operating system, and the Arduino was just scheduling a lot of time on the operating system rather than Python. So if you could do a low-level language like C, Rust, these are things that if your CPU, your silicon is limited by default, then it's probably very important for you to do important memory management of Rust. And this is what I think the takeaway that I have from Rust. Prototyping, especially a thing like Eclipse simulation, to make sure that to prove that I'm better than my wife at board gaming, maybe it's not the right thing to do. But I'm excited for my next server project, something to do with memory management where this thing will come, where I can leverage the power of Rust. Pick the right language for the right tool, for the right job.
I'm curious, how long did it take for you to prototype this in Rust, and how long do you think it might have taken to prototype it in a language that you feel more comfortable with?
I think like 4 hours to 1 hour. So I took 4 hours to this. And I think I could have easily done it in like hour, yeah, 4 to 1. And I wouldn't have given up as well. I would have continued working on all the other features as well. And in fact, ask you this: if I wanted to do graphs and charts and anything for visualization onto a website, I think it would make much more sense to use JavaScript anyway, because it's right next to HTML, right? You want to render anything. There are lots of like rendering frameworks on NPM that allows you to just create a website and then just post your graphs there. Rust, then I need to figure out what is the converter from Rust that generates my HTML for me, and then so on and so forth.
Since we're talking about HTML and websites, what do you think about the use case of Rust on WebAssembly stuff? Because I think there's some sort of application there as well. But is it only maybe for server-side projects, or is there a good spotlight for us on the web?
So of course, this is an opinion, and everyone, you find a room of 10 engineers, you get 10 different opinions. And I actually think that Rust is not the right tool for web development. As in, web, I mean, yeah, can you find a web plugin for Rust? For sure you can, I'm sure it's there. But I think that, given the maturity of the JavaScript ecosystem and its like friendliness of HTML, it was literally written to be on the browser. I think that Rust is good for its own thing. Like I said a few sentences ago, pick the right tool for the right job. But I think Rust is very good at what it does, but maybe not web.
Just one comment on that. I think since HTMX is kind of actually coming, which is kind of changing the paradigm, it could be that in combination with that, if you like writing Rust for the backend, that's a good way, right? Like that's circumventing the way that React and so on do it. But,
how do you make a graph?
well, HTMX is kind of the core idea is that you drive the full state. You don't have like a complex state management system in the browser. So the state is managed by the backend, right? Yeah. And then, but you essentially just have like your handler functions for if the user clicks a button or any event that you handle in Rust, and then the HTMX library makes it very comfortable to build an application in that form.
So I argue you can make HTML, you can make H1s, headers, paragraphs, but like, there's already a lot of graphing tools in.
Yeah, I fully agree. So HTMX, the idea is like you just write HTML and you embed the logic into HTML, and that decouples it much more from the backend in a sense, where you're now free to use whichever language you want, but you're not using like a normal REST API or GraphQL API. You're using your application logic is actually also largely managed by the backend in that case. So that's like a combination of Rust and HTML.
Yeah. Anyone else want to ask questions? Yeah.
So for me, if I want to get started on Rust, basically, it's a very shallow question actually, but the idea is basically, what would be your recommendation of best IDE, like for Java, IntelliJ is kind of a default, for Python is PyCharm.
I actually had a very good time with Visual Studio Code. VS Code was perfectly fine. The interpreter was super fast. The errors were fast. The recommendations and suggestions were good. There's absolutely nothing wrong with VS Code. It's free and fast.
Make sure to use the Rust analyzer.
So the VS Code has add-ons you can add. So make sure you download the right Rust analyzer, which does it like that.
Nothing from JetBrains.
They just released something. JetBrains just released something.
They call it Rust Rover or something.
Yeah,
from JetBrains.
Yeah, they just released something.
I think it's free in the beginning, but they're saying they're going to charge us something because it's experimental.
Someone's the videos, right?
Yeah,
and like JetBrains also made Kotlin, so like they're already on zero.
Okay. Any more questions? Yep, free.
So I'm kind of also new, and I went through the phase of what you said with the uppercase string and str.
Yeah.
So now I think I understand why they did it that way, and I want to challenge you to ask you, like, how would you think, like, what do you want Rust to do with a string? Because maybe that helps others as well. Because I think I can justify why.
Just one string. He just want one string.
Okay,
not three, not five. One string.
Yeah, I think
you just want one string. Always just stick to uppercase string.
Oh, so then I just need to cast everything to uppercase string.
Well, if you define a string literal, then you have to, like, there are multiple ways. There's like try from, where you do your literal string expression, and then you need to do like to string. Yeah. But then you just stick with that one, and that's the default. Right?
Yeah.
Because the and str, that's like a lower level abstraction. What that says is look, I'm pointing to some location in memory, because if you write that in your code, that's literally the string in the executable file, right? Which is loaded like in the data section or VSS section, data section of your executable. And that str is just saying like, yo, this string, this piece of memory where this is baked in that never changes, just read that from there. Or if, like, And the uppercase string, all of that is like, that's a thing with ownership and then lifetimes are managed. But with it and str, it's just like, yo, I'm pointing there. This thing is going to be there forever. Just read it, right? That's what it is saying.
I think one of the reasons I kind of thought I should know the answer, but I think one of the reasons is, like if you're doing embedded programming, like allocating memory, you can't do. So you can't use a string because that allocates memory. You have to use an str everywhere. So the Rust library is split into two. It's actually the core and the std.
Wow.
And core, I've never used it, but I think it, you have much. A lot of anything that allocates memory is an std, I think. And so, like for embedded programming, low level hardware, I think many times you don't have an allocator.
I'm just being mindful of time. Any last questions, comments, feedback? You guys enjoying so far? Oh, fantastic, fantastic. Thank you, Dylan.
Cool.
I wanted Dylan to join me because I knew he had an opinion.